SpaceX is ready to catch the world's largest rocket with a pair of giant robot chopstick arms, and we will be telling you all about them in today's video. The mind-blowing Mechazilla is going to be solely responsible for catching and helping launch the Starship this year. How will these robotic arms catch a rocket flying at a speed of thousands of kilometers? What is its structure like and how big is it? Hang on to your seats as we tell you all about this. Let's talk about the SpaceX Mechazilla. This is the massive robotic launch and landing tower that will catch Starship rockets out of the sky with chopstick arms in the not-too-distant future. Elon Musk and the SpaceX engineers have come up with an incredible and fantastic idea. But this isn't about showing off the company's genius. It's strictly a business choice that will benefit future launches. SpaceX will try to catch the largest ever flying object with robot chopsticks. Success is not guaranteed, but excitement is. Since Elon initially tweeted that they were going to try to catch the super heavy booster with the launch tower arm a year or so ago, there has been no end to the debate over how exactly such a thing would happen. But things are beginning to change. The Mechazilla began to come alive and flex its muscles last year. Furthermore, Elon has released the first official SpaceX render of how a booster catch would appear. Let's start at the beginning and figure out why SpaceX is doing all of this robot catching in the first place. They've already worked out how to land the Falcon 9 rocket on its legs, which is a task that no other aerospace company has achieved, even years after the creation of the Falcon. A Falcon 9 first-stage rocket successfully landed on the ground at Cape Canaveral on December 2015, which had never been done before. Why would SpaceX feel the need to raise the bar if they're already at the top? When someone asked Elon if the Super Heavy would descend to land in the same way as a Falcon 9, he revealed the answer on December 2020 on his Twitter, saying, "We're going to try to catch the Super Heavy booster with the launch tower arm, using the grid fins to take the load." So, if the Super Heavy lands on the landing pad like the initial Starship testing did, it'll require a lot of effort to get it back on the launch mount, even if it's only a short distance away. They'd need a mobile crane as well as the massive tank track transport truck that Starbase uses to move rockets. The crane would have to lift up the booster, set it on the transport, and then carry the entire craft to the launch mount. Then use the crane to reposition the booster on the mount and finally drive both of the massive machines back to the hangar. In addition to being heavy, expensive, and complicated, landing legs can also be quite fragile and require a lot of care. Take the Falcon 9 for example. The rocket is light, but it descends with a lot of power that the legs must absorb. The Falcon's legs don't have shock absorbers, but they do have a crumple zone to absorb the energy. The crush cores, as SpaceX calls them, are honeycomb-style capsules inside the legs that compress on landing. And of course, these must be replaced after each landing. In the case of the Starship, the replacement would be extremely costly as the rocket is nearly 11 million pounds, and SpaceX plans to reuse the rocket around 2 to 3 times a day in a couple of decades when humans start colonizing Mars. So, how will the Mechazilla work? This 145-meter tall steel structure is known to be at the heart of the launch/landing tower. We also know that the Mechazilla has 3 robotic arms, one of which is a rapid disconnect arm that acts as a mid-rocket stabilizer to reduce the impact. The 2 remaining arms will team up to capture and take up spaceships. The chopsticks, in this case, are 36-meter-long tubular steel beams. A highly complex system of the arms mechanically drives the arms up and down along a rail track on the tower. The draw cables are driven by 4 massive electric motors situated at the bottom of the tower, which produce 6,000 horsepower in total. This device was adapted from an oil rig and is used to drop and retract drills from the ocean's depths. Hydraulic cylinders also control the pinching motion of the chopsticks. In terms of how the booster and chopsticks will work together, Elon's tweet on January 19th of a SpaceX computer render finally offers us a fair picture of how the landing will go. As a result, the final landing burn starts at around 1,800 meters, which is around the same altitude as a Falcon 9's burn. Like the Falcon 9, Super Heavy will come down at an angle, like a javelin, rather than straight up and down. The purpose for this is so that the rocket's surface area hits the atmosphere and creates drag, or lift, depending on whichever term you choose. The Super Heavy, unlike the Falcon, will use 9 engines at the peak of its landing burn, which will be linked to a motorized gimbal system that allows the engine nozzles to rotate around and maneuver the rocket as well. Hold on, viewers. If you've made it to this point of the video, we'd like to thank you. We'd love for you to show your support by subscribing to our channel and liking this video. Now, let's continue. How will Starship's landing be slowed down to fit perfectly into the arms of the Mechazilla? 6 of the engines will shut down at the height of around 800 meters, leaving only 3 Raptors to tilt the rocket and bring it down into a controlled hover between the Mechazilla's waiting arms. The arms of this tower will be shifted to the side, away from the launch mount, because SpaceX does not want the booster to land right on top of the launch mount because it is costly and labor demanding to create. The boosters and the ships are cheap, but the ground equipment is not. At roughly 65 meters above the Earth, the Super Heavy is hovering, and 2 more engines have been cut off, leaving only 1 engine to shut down as the chopsticks reach up to grip 2 pins on the sides of the booster, just beneath the grid fins. This differs from what most 3D artists had previously anticipated, in which the booster would crash down with force, and the arms would fold and absorb the energy. According to Elon's illustration, the booster comes to a complete stop and hovers for around 5 seconds before being pinched by the chopsticks. According to this rendering, the sticks will move very little during the catch movement, and they won't sag down like a shock absorber. We know that the catch rails on the chopstick arms can move a few inches up and down, and that's probably all that's needed to absorb the booster's weight, just like the Falcon 9. We're used to seeing the Falcon 9 make a hard landing. This is known as a suicide burn, because if it's too short, the rocket will hit the ground hard and explode. But if it's too long, the rocket will bounce off the ground, go back up, tip over, and explode. We've seen both cases happen to the Falcons in the past, and the reason for this is because in order to save as much fuel as possible, hovering for even a few seconds requires a large amount of fuel to be kept in reserve. This raises an interesting question. Will the Super Heavy be able to hit such a small landing target? Yes, it shouldn't be a problem. We may also compare it to the Falcon 9, which can land in a relatively narrow radius, even on a ship in the ocean. Falcon boosters almost always land dead center on the pad when they land on the ground. The Falcon can only steer with its grid fins as it lacks gimbaled engines and the ability to hover. Though there may be some doubts about the success of this innovative mechanism, we certainly are looking forward to seeing it in action. Let us know your thoughts about the Mechazilla in the comments section down below. That's all for today's video. Thanks for watching. We'll see you in the next one.